Further to this, the nigrostriatal pathway can activate the thalamus and hence motor cortex by two pathways, directly and indirectly. It excites the direct pathway and inhibits the indirect pathway. To investigate what is happening in Ted's case, we'll look at these pathways in more depth. It is important to note that ultimately the basal ganglia's role is to adjust how active the thalamus can be in exciting the motor cortex. The direct pathway works to activate the thalamus, which ultimately increases movement. In healthy patients, the substantia nigra would send dopamine signals to the striatum in order to excite the thalamus and increase movement. However, in Ted's case study, it can be expected that the substantia nigra has lost dopamine neurons and therefore cannot effectively excite the thalamus to produce the amount of movement required. Therefore, this explains Ted's trouble with initiation of movements and his slowness in general. The indirect pathway, which is the inhibitory pathway, works to decrease activation of the thalamus and ultimately reduces movement. In this case, the substantia nigra's role is to fine-tune the slowing down of muscles, such as when we're going from running to walking. The substantia nigra uses the dopamine to make sure muscle activity isn't slowed down too quickly. So Ted's loss of dopamine neurons means the substantia nigra cannot send enough dopamine to the striatum, leading to a reduced inhibitory effect on the subthalamic nucleus, which becomes more active than usual in inhibiting activation of the cortex, which is where you will see bradykinesia. So this can explain the jerking of movements in Ted's case study and the resting tremors of his hands that he is experiencing. In Parkinson's disease, the indirect pathway is excited more so than the direct pathway and hence leads to an overall greater inhibition to the motor cortex.